Hi everyone, for this video we're going to discuss the different laws or different rules and properties of logarithms. So in the previous video we say that the logarithm function is the inverse of exponential function. So it's the same thing with the laws. So let's start with the product law. So we have the logarithm of a product. So this is equal to the logarithm of a plus the logarithm of b. If you remember in exponential law, the product law, so if we have x raised to a times x raised to b, so if it's the same base, we add the indices or the exponents. Now next is the quotient law. So it's the logarithm of a over b. So if you remember in exponential, if it's like x raised to the a power over x raised to the b power, we subtract the exponent. So for logarithm, this would be the logarithm of a minus the logarithm of b. Next one is the logarithm of a power. So example, you have the logarithm of a raised to n. Remember, in exponential, the power law, for example, you have x raised to m raised to the nth power. So we multiply the indices or exponents. So this will be x raised to m times n. So for logarithm, what will we do is we multiply n times the logarithm of a. Okay, let's have some examples. Let's say we have the logarithm of base 2 of 16 times 8. So using the product rule, we have the logarithm of 16 base 2 plus the logarithm of 8 base 2. So let's evaluate this. Logarithm of 16 base 2 means what is the exponent of 2 to give us 16. So that is 2 to the 4th power. So logarithm of 16 base 2 is 4. And then logarithm of 8 base 2 would be equal to 3. So this is equal to 7. Let's have another example. Let's say we have logarithm of 8 times 4 base 2. So we can do logarithm of 8 to the base 2 plus logarithm of 4 to the base 2. So the logarithm of 8 to the base 2 is 3. And the logarithm of 4 to the base 2 is 2. So 3 plus 2 is 5. Or we can do logarithm of, what's 8 times 4? 32 to the base 2. So what would be the exponent of 2 or index of 2 to give us 32? And that is 5. So we can do that. Next, let's have the logarithm of 9 times 81 to the base 3. So this is logarithm of 9 to the base 3 plus the logarithm of 81 to the base 3. This is equal to 2, and 3 to the 4 is 81. So the answer is 6. Okay, let's have the logarithm of 64 over 2 to the base 2. So we can express this or expand this as logarithm of 64 to the base 2 minus the logarithm of 2 base 2. So the logarithm of 64 to the base 2 is equal to 6 minus, because it's division, logarithm of 2 to the base 2 is 1. So 6 minus 1 is 5. And we can check this by simplifying. So let's say from here, so 64 over 2 is 32. So that's the logarithm of 32 to the base 2. So what is the exponent or index of 2 to get 32? And that is 5. Now let's have the logarithm of 9 to the 5th power to the base 3. Okay, so the power rule is we put 5 here times the logarithm of 9 to the base 3. So 5 times logarithm of 9 to the base 3 is 2. So this is equal to 10. Let's have another example. Let's say we have a logarithm of 4 raised to the 8th power to the base 4. So we can do this 8 times the logarithm of 4 to the base 4. So 8 times logarithm of 4 to the base 4 is equal to 1. So 8 times 1 is 8. Now let's try this example. Write logarithm of 16 minus logarithm of 2 as a single logarithm. Since we know that one of the rules of logarithm, the quotient rule, is to subtract its logarithm, so we can express this as the logarithm of 16 over 2. So this would be logarithm of 16 over 2 is 8. And we can still simplify this. 8 is 2 cubed. And this one is a power law. So simplifying, we'll get 3 times the logarithm of 2. So this is the final answer. Alright, let's try this one. Expand the logarithm of 125 over 64. As we know that this is the quotient law from the second law of logarithm, so we can write this as the logarithm of 125 minus the logarithm of 64. And we can express 125 as the logarithm of 5 cubed, and logarithm 64 will be 4 cubed. And from the power law of logarithm, we can write this as 3 times the logarithm of 5 minus 3 times the logarithm of 4. Simplifying or factoring 3 out, so we have 3 times the logarithm of 5 minus the logarithm of 4. I just want to leave you with 2 other important logarithm notes is that the logarithm of 1 to any base is equal to 0, because we know that b, or any base raised to the 0 power, is equal to 1. And also, the logarithm of a number to the same base, so let's say a to the base a, is equal to 1. Because in exponential function, we have a base raised to 1 is equal to a. Thank you, and we'll see you in the next video.